Hi, Nico.
Hi, Markus.
We gratefully could sell the first 12-meter line to Open Group in Mexico, who benefit from a reduced overall specific energy input, for example. Well, a 12-meter line, that's something new.
I mean, it's not that simple just to take a 10-meter line and stretch it by 2 meters and things are done. So you have to go from the start, from the extruder, for example. So you have the throughput, which is increasing by 20%. That's already a challenge. Going through the entire line, the oven gets wider, so you need to ensure uniformity in the oven. And then probably the component which we are most proud of is the winder, because the winder holds a 49-ton master roll, and that's really world record.
49 tons. How would that explain in meters of film on it?
It's 171,000 meters of film, so 171 kilometers, basically the distance between Munich and Salzburg.
We've been happy that your team has been built together a new and super fast line, the world's first 700 meter a minute, 10.5 meter polyester line. What did we do there to make it happen that we can achieve 700 meters successfully?
That's our big advantage as Brückner, that we are into different product categories. So we already have a line running in the BOPP universe with 700 meters a minute. Our customer Cosmo in India.
Right.
And so we basically transferred the gliding chain, 700 meters per minute, into a BOPET line. Here we can benefit from the technology exchange from one product group into another product group.
Right. And just in China, it was reported that the year-on-year growth of the usage of the battery separator film was more than 40%. And it did not only go into the electric vehicles, which we believe once, but it also went more and more into the power storage systems. I realized that the gauges are getting smaller and smaller. Why is that?
5 micron BSF film thickness is currently the talk of the town. Basically, the idea is to increase the energy density of the batteries. And the thinner the film is, the higher the capacity of the battery, or the energy density of the battery is. And so we're working together with customers to realize these 5 micron film thickness. Okay. But the thickness itself is not a big issue. I mean, we are already producing 5 micron. The key question is to have a high puncture strength of this film, because in a crash situation, of course, the batteries should still be stable and you should avoid a thermal runaway. And so this is something we're currently working on. And that also means that the stretching ratios in both dimensions, TD and MD, increase significantly. So we're talking about 20 stretching ratio in TD direction and 20 stretching ratio in MD direction. So that's a challenge, but of course it's feasible.
Yeah. What is about the capacitor film, which is on the thicker end? We understood that by utilizing this high voltage DC transfer of electricity, it's like China or Canada, they have 6,000-7,000 meter long grids. And those grids are now more and more coming on the DC power rather than AC. And therefore, obviously, capacitors are needed to make a transformation. What we have for those specific applications?
I mean, this is also an application area where the DSIM comes into the game, because it produces high quality film. And we're currently working together with customers to increase the thickness of the capacitor film from the DSIM from below 5 micron to levels up to 5 or even 6 microns, which are then suitable for such kind of applications in the power grids.
I saw that comment from our customers. They're very appreciating the standard data interface, SDI, because it gives them the opportunity to combine things, but also to combine different locations.
That's one thing, to connect different lines. And the other thing is, as this interface is standardized and is already available right at the beginning, it simplifies the entire process of connectivity at the customer side. You don't need to sit down with the customer and define what kind of data elements you want to use. We have them already available, and the customer can use them right from the first day.
We're also having different technology centers across our platform companies. What's there in the pipeline?
So the major technology hub will be here in Siegsdorf, and if I turn around, basically here, in roughly 3 years' time, we will have a new custom innovation center. So
great.
This will be a great building on one hand, but of course it will be furnished with 2 lines, so one sequential line and one simultaneous line. So we're expanding our trial capacity by 100%, as we are having 2 lines today. We have 1 line. So we are very much looking forward to use this new Custom Innovation Center to develop new technologies together with our customers and partners, and to thrill the world with new innovations. And even further, this is only the facility here in Siegsdorf, but we're also expanding our trial facilities all over the world. So we have already in the US, in Dover, in our platform company, a laboratory stretch system, the so-called CARO system. And we are going to establish exactly the same also in China, in Suzhou, in our new facility. We're also building a new facility in China, which will be...
The new dragon, I've heard.
Yeah, exactly, which will be introduced and opened beginning of 2027. And there we will have also a laboratory stretcher, but also a cast line. So we can use materials provided by our customers, produce the base film, and then stretch the base film in order to do trials with our customers.
Yeah, and I think our global customers will love it, because always come to Siegsdorf is nice, but having the facilities next to our customers' place is even better.
Yeah, stretching the limits across the globe.
Stretching the limits.